You know what always amazed me? Since childhood, they paint us a picture of the world like we're watching a short video on fast forward. Everything explodes, everything flies apart, everything cools down, life appears. You are born, and it's presented like there are no questions at all. Yeah, Big Bang, space, stars, planets. Then somehow life appears by itself. Evolution, monkeys, humans. Thanks. You can go home. But the older you get, the clearer you catch one uncomfortable thing. Matter is one thing, and life is something completely different. A stone is matter. Water is matter. Even a star is just matter too, just extremely hot matter. But DNA is not just matter. DNA is an instruction, a code, a program. So yes, an explosion is an event. But DNA is a system that somehow knows what to do. And today, I want to talk about that. I'm going to show you something simple, where the Big Bang Theory is genuinely strong, where the honest holes begin, and why DNA is the main glitch in the official picture of the world. Because sure, anyone can blow something up, but for an explosion to produce code and instruction and meaning, that already requires something more than just a bang. Call it whatever you want, intelligence, an algorithm, or the matrix. Let's go. First, honestly, if you only listen to school, the story is simple. There was nothing. Then, boom, everything appeared. Billions of years later. You. Sounds epic, but it's a little too Hollywood. In reality, the Big Bang Theory isn't about a bomb exploding in space. It's about the idea that the entire universe was once in an ultra-dense, ultra-hot state. Then it began to expand and cool. And from that moment, our cosmic timeline started. And this is where physics is actually doing great. Galaxies are moving apart. We can see it. The cosmic microwave background exists, like an echo of the early hot universe. The distribution of chemical elements mostly fits the model too. In other words, how the stage appeared, iron, gas, stones, the raw materials. This part is explained more or less convincingly. But then the editing gets weird. On that stage, suddenly, out of nowhere, appear the first molecules that can store information. Then structures emerge that can copy themselves. Then it turns into cells, and then into living organisms that can think and ask questions. And what the hell happened at the beginning? This is where the substitution happens. They still explain something about the birth of matter, but how the code of life appeared, most of the time they just blur it with one magical phrase. Well, then life formed. Then? How exactly then? Then is the favorite word used exactly where logic ends. The Big Bang explains the stage. But it doesn't explain the script. It's like someone told you, we built a massive film studio, sets, lighting, cameras, equipment, and then the script, the actors, and the editing, they just somehow assembled themselves. Randomly, after a billion years of trying. You're already laughing, right? That's exactly how part of the modern myth about life sounds. Imagine a printing house, a gigantic hall, thousands of boxes filled with letters, tons of paper, oceans of ink, and imagine they threw a grenade inside. What happens after the explosion? Paper flies all over the room. Ink smears across the floor. Letters scatter in every direction. Walls get stained and shattered. Chaos. Pure entropy. Now the main question. Could a series of such explosions accidentally produce war and peace? Not scraps of words, not random fragments, but a clean, multi-volume text with characters, plot, logic. Not a paragraph, but an entire system of meaning. And right there, even the most devoted, everything is random believer goes quiet. Because chaos is good at destroying structure, but it is not good at creating it. Now transfer that image to DNA. DNA is not just a chemical soup. It's a line where information is written. It encodes how to assemble you, how to launch you, how to maintain you, how to repair you, how to pass you forward. Not just something reacts somewhere. An actual instruction where order, sequence, and context matter. Chemistry can provide material. But for code to appear, you don't just need a lot of time. You need a rule, an algorithm, logic. And here we hit the core question. Can the Big Bang explain the appearance of bricks? Yes. Can it explain the appearance of a blueprint for a house and the meaning of why it's being built? Not yet. Let's break DNA down in simple terms. No biochemistry lecture. Imagine a flash drive. On it is a program. You plug it into a computer and the program runs. It executes commands, creates files, draws things, controls processes. DNA in your cell is basically that flash drive. It contains the color of your eyes, the shape of your nose, your height, the features of your nervous system, how you react to stress, even predispositions to certain diseases. DNA is the assembly code for your avatar. What does this code do? 1. It stores information, stable across generations. 2. It copies itself. Every new cell, every division. The instruction gets passed along. 3. It repairs errors. Whole repair systems exist that fix damage. So DNA is text, archive, program, and editor, all at once. Now let's ask honestly, what's easier, randomly assembling a stone or randomly writing a working program? A stone can appear a billion times. It doesn't need to know how to be a stone. It just exists. But a molecule that knows how to copy itself, store information, and launch reactions, that's a different league. That's code. Now without extremes. No need to scream, science knows nothing. That's not true. But everything is already explained is a fairy tale too. So what have scientists actually managed to do in laboratories? They created bricks of life. In famous experiments like Miller-Urey, researchers took simple gases, added energy, sparks, heat, and produced amino acids, the building blocks of proteins. Conclusion: organic molecules can form naturally. They created microcapsules that resemble cells. Some molecules spontaneously assemble into membrane-like bubbles, protocells, that can hold other substances inside. Conclusion: nature can build containers for life. They found molecules that look like a transitional step, RNA. RNA can store information and participate in chemical reactions. There's a hypothesis that there was an RNA world first, and later it evolved into DNA plus proteins. Conclusion: there are hints of a possible path from chemistry to something more complex. But here's the big but. No one has still shown how from a messy chemical soup, a molecule appears on its own that can reliably copy itself, without a human in a lab coat, without fine-tuning, without carefully selected conditions. That is the key boundary. And honestly, it hasn't been crossed yet. There are models, hypotheses, sketches, but there is still no experiment that goes, we created conditions. And here you go, a molecule that copies itself and starts the cycle of life. And that's exactly why the DNA question remains a hole in the script. Chemistry is not the same thing as code. Matter is not the same thing as meaning. When all arguments run out, people usually reach for a magic spell. Well, there was a lot of time. Over billions of years, anything could happen. It sounds comforting, but let's bring it down to earth. Imagine a junkyard. Old electronics, circuit boards, wires, metal scraps. Now imagine wind blowing for billions of years, rain, lightning, rocks falling, random impacts, random reactions. Question: after a billion years, do we expect to find a working laptop in that pile, with an operating system? Or do we expect to find the same chaos, just rearranged? Time can rust, destroy, mix, and redistribute. But time does not replace architecture. Time does not replace an algorithm. If you don't have a rule of assembly, if no one filters the trash and keeps what matters, then billions of years simply increase the number of chaotic states. They don't turn chaos into meaningful structure. That's why the phrase random but over a long time isn't an answer. It's a beautiful excuse. It covers a hole where the honest answer sounds like this: we don't know how chemistry became code. Not yet, and that's okay. But if we were left with an empty space, We have every right to ask our own question and consider alternatives. To be fair, let's quickly run through the main explanations offered within classical science, calmly, without mockery. Version A. The primordial soup. Warm oceans, lightning, volcanoes, a chemical stew. Over time, complex molecules appear, and then the first primitive living systems. Beautiful. This picture worked like a myth for a whole century. But how exactly did the first self-copying system appear from the soup? Why didn't it fall apart immediately? How did it hold its structure long enough to continue? There is no clear answer, only general phrases. Version B. The RNA world. They say, first came RNA. It's simpler than DNA. It can store information and help reactions happen. So it could have been the first step. The idea is logical. But then we hit the same wall. How did RNA appear in the first place, specifically in a form capable of copying itself, not just lying there in the soup? Version C. Deep-sea hydrothermal vents. Black smokers. Hot springs on the ocean floor. Heat. Chemical gradients. Energy. An ideal natural reactor. It looks great for documentaries. The physics and chemistry are genuinely interesting there. But they explain energy flows, not the emergence of code. Version D. Panspermia. Life came from space. Spores delivered by meteors, comets, asteroids. On the level of, why not? It's possible. But then we simply move the question elsewhere. Okay, then how did the first self-replicating system appear? So at every official turning point, we end up stuck with the same question. Who wrote the first line of code? And here, the Big Bang no longer helps. The Big Bang is about the stage. We're talking about the script. Now we switch on the part you're actually here for. If we set aside religious, mystical, and pseudoscientific fairy tales, we can phrase the thought carefully. Maybe information is primary. Not matter, information. Meaning, first there is a rule, an algorithm, a structure, a meaning, and only then does material grow around it. Atoms, molecules, cells. This is how games work. First you write the game code, rules, physics, behavior of characters, and only then do you load graphics, models, textures. In that logic, the Big Bang is simply the moment the engine starts. The system turns on, the timer begins, background processes launch, and life is the moment the engine gains a layer of programs that work with feedback, learn, evolve, and at some point begin to recognize themselves. So the code was not a consequence of the bang. The code was the purpose of it. And the deeper you look at DNA, the stronger the feeling becomes. This isn't just chemistry. This is someone's language, maybe the language of reality itself. And that's where many people ask, okay, but if this is all code, matrix, simulation, what does that mean for me? How do I live? This is where it gets interesting. If the world is just a random discharge of matter, then your life carries no meaning. You are a bundle of chemical reactions. Your feelings are just biochemistry. Everything ends anyway, so don't worry about it. But if the world is coded, and life is not an accident but a launched process, then the whole picture changes. It means your individuality isn't random. Your character, your talent, your inclinations aren't trash. They're part of the script. Your path isn't just survive or die. It's experience through which the code learns itself. In that picture, your choice matters. Your focus matters. Your energy matters, because the code doesn't exist in abstraction. It manifests through you. And that's where the Big Bang and DNA stop being a dry lecture and become a mirror. A logical question follows. If it's all code, am I just a program too, and nothing can be changed? Here's the subtle point. There is a layer that is hard-written. You were born at a certain time with a certain body, a certain nervous system, a set of weaknesses and strengths, like the base configuration of a character in a game. But then another level activates. Consciousness. Consciousness is what can change reactions, redirect attention, rewrite habits. expand your view of the world, shift the script. So yes, there is code that launched you, but there is also the ability to build new layers on top of it. That's the whole point. If you believe you are just a side effect of an explosion, you live like a random object. But if you begin to perceive yourself as part of a complex system, where information and consciousness are primary, then you begin to choose differently, treat yourself differently, and see the world differently. And maybe that's exactly what the Matrix needs. Something to awaken inside its own rules. Something that starts to recognize the game. I'm not asking you to throw away every textbook today and join a simulation cult. I'm offering something else. Stop pretending the official story. Everything exploded and then you appeared. Answers all questions. It answers part of them. But it doesn't explain why meaning emerged inside matter, or who wrote the first line of code. If you feel that, and then life formed isn't enough for you, then you've already stepped beyond the school picture. From here, it's a personal choice. You can close your eyes and say, it's easier for me. Let it just be an explosion. Or you can keep observing how the world sometimes aligns too precisely with your thoughts, how events arrange themselves with impossible timing, how life responds to your inner state and focus, how the code around you seems to answer your internal signals. And then the Matrix theory stops being a movie and becomes a practice. Thank you for staying with me to the end. Thank you for your attention and your awareness. Stay on your best timeline. See you in the next video.